In this lecture, we are going to summarize everything we learned in this section. To be quite honest, this section became a lot longer than I had originally anticipated. But this just goes to show how much there is to learn about the basics of finance. If you think you're going to become a billionaire using an LSTM to predict tomorrow's stock prices, you would have already made one in the time it took you to get through this section. In this section, our goal was to understand the central measurement we want to model in finance, which, unbeknownst to many, is actually the stock return and not the stock price. This section was all about how to model the stock return. In fact, even after this section, we will continue to discuss how one might model the stock return. We started by looking at some extremely basic questions like, where does one download financial data, and what does financial data look like? This section was all about how to model the stock return as a non-time-varying random variable. We investigated whether or not the stock return might be modeled by a normal distribution. We found that, based on the QQ plot and several statistical tests, that this is probably not the case. We then looked at the t-distribution, which seemed to work better. The t-distribution is a fundamental distribution in statistics, as it forms the basis of the t-test and the confidence interval. We looked at several quantities of interest when it comes to stock returns, including the skewness, kurtosis, correlation, and covariance. We looked at the meaning of alpha and beta, two very popular words in finance. This was our first application of machine learning. We looked at how a Gaussian mixture model might be used to model stock returns. This was our second application of machine learning. We then looked at volatility clustering. This might suggest that, instead of a static model like a Gaussian mixture, perhaps a time-varying model might be even better. Finally, we looked at how to simulate stock prices, which is very important for testing the effectiveness and robustness of an algorithm.